Okay, we're up and running. Welcome everyone. Nice to see you all. So this is for the coin fountain. And what number is that where the two arcs intersect? Okay, number 10. And yeah, this is a little bit difficult, but not completely horrible. So you all have designed a beautiful arc. Let's say it went a launch of 3 and a landing of 17. And then let's say it went, I don't know, 14 and 20. So at some point there's an intersection, this green point right here. And I think it helps if you conceptualize this first arc, the blue one, as a set of points that follow a predicted path of behavior. So this is an XY, and this is an XY, and this is an XY, and they're a set of all those X's and Y's. And the red arc is also a second set of X's and Y's and X's and Y's and X's and Y's. And right here, they have this special green point that those coordinates, that X and that Y, are in both sets of numbers. And that's a good way to think of this, as a set of numbers. Okay. So then let's come up with something that's realistic. Maybe not what you have. We would have for the blue y equals a times what? X minus 3 times x minus 17, good. And then the red one, y equals some other a times x minus 14 times x minus 20. And now, will you all find me some a's that are just pseudo-realistic? Let's not go, we can go crazy on this one. We don't have to follow that many rules. Find some a's that work. And I'll multiply this out. X squared minus 20x plus 51. Y equals x squared minus 34x plus 280. Give me some a's that are even pseudo kind of work. 0.1. Oh, negative 0.1. That could help, yeah. Negative 0.1 for that. How high does that go? How high does that go? Come on. It's not that tough. Just graph it. Go second calc max real fast. Because I want it to be sort of realistic. Graph 0.1. When you're young, you know, in grade school, if you can make armpit farts, you know, some girl will like you. But now that we're in high school and we're more, really college, we're more sophisticated in that. You need to impress a person by being good at math, clearly. Right. And Brett's family, Brett is handsome and funny, and Brett's family is wealthy, and you know, so you're trying to impress this dude, right? Good. And so you are going to find the coordinates for the point of intersection algebraically. And then you're going to check it graphically, okay? So let's keep this in mind. We do have an intersection. We're going to check it later. Now, knowing that these points here are in the same set, Riley, in the same set, how can we find this green point of intersection algebraically? I bet you do. I bet you do, Riley. Because if I had given you two lines, you know, just that, or line segments, whatever, that intersect, and if I said like this, you know, y equals 3x plus 4, and y sub 1 and y sub 2 equals negative 2x minus 5. or something like that. Could you solve this to find the point of intersection? Sure. You would do what, Riley? You could substitute, or you can set them equal to each other. You could say this. There's lots of ways to solve it. Systems of equations, we've been doing those forever. Then what would you do, Riley? Yeah, solve for x, of course. And then you'd go, yeah, sure, plus 2x minus 4, right? Plus 2x over here. Minus 4. Solving, what do you get? 5x equals negative 9, right? X equals negative 9/5. Then find y. We've been doing that forever. But then I hit you with one of these guys, and you freak out. You do the same thing. They're the same set. I mean, this green point here is in both sets, so I can say this equals this at that point only, okay, which is really cool. So now I can say negative x squared plus 20x minus 51 equals negative 0.5x squared plus 17x minus 140. Okay, this is nice. Carol, how are you today? Glad to hear it. Now, talk to me about how we could solve this one, Carol. Because Riley's right. We're going to solve for x. What could we do? Okay, we could do that. We could say negative x squared plus 3x minus 51 equals negative 0.5x squared minus 140. Okay, excellent. Add 0.5x. I can do that. I can do that. So that'll give me negative 3/2 x, or no, I added, didn't I? So 1/2. Don't let me do that, y'all. Negative 1/2 x squared plus 3x minus 51 equals negative 140. Carol, you're on a roll. Keep going. I think it'd be better to try to get everything on one side. Add 140. Then we have negative 1/2 x squared plus 3x. 140 and 51. What is that? 140 and 51. Well, if it was 40, it'd be 100. What is that? 90 how much? 91. Okay. Plus 91. No, I don't believe that. 89. Let's try that. Let's try that. I think she's right. 89 and 51. Yes, that works. Now, equals 0. Don't forget the 0. This is nice. So far, Zach, are you shaking your head? Are we okay, Zach? No, I said Carol. Dude, keep up. Come on.
I'm pretty sure you called Zach a she.
I don't think so. And even if I did, we celebrate our feminine side always. Always. Right? Right? Listen, you guys, men have been pigs for like 200 years. It's time for the next 200 years for us to be really nice and celebrate our feminine side and be cool for 200 years. After that, you can revert to being pigs again. Okay? How do you know? They might have a longevity pill by the time you're 100, Kai. All right, let's stay focused. Let's stay focused. Now, who haven't I picked on yet? Ty. I will pick on everybody before we're done. How are we going to solve for x? I think we just got them over here with great effort so that we can use something. Yeah, a special box. What does A equal? Negative 1/2. Close. What's B? Yeah. Okay. I want everyone right now to solve for X and then check with second calc intersect. Okay? And I'm going to pause the recording for now and let everybody... okay, good. Now, Tucker, tell me what you got when you plugged this into the quadratic formula. What kind of a cool answer did you get? Beautiful, beautiful. And that is correct. I see a bunch of people saluting you and clapping and high-fiving. 3 plus and minus the square root of 187. Now, this is interesting. This is interesting. And then what most people did, and this is fine, then they said that is X is approximately equal to 3 plus, what was it, 13 point something? 13.6, or 3 minus 13.6. 0.7? 0.7 then, that's fine. We want to be about, right? Keep in mind that your calculator will give you all these decimals, but if you're measuring your launch point to the nearest foot or something, or nearest half a foot, all those decimals become kind of meaningless. We were talking about that earlier. We generally hear if you're given something to the nearest foot, then you report your answer 1 decimal point, and other to the nearest tenth of a foot. So this is about then X is approximately equal to 16.7, or what is that? Negative 10.7. Now, then, this is really important. Danger Will Robinson right here. Say to yourself, does my answer make sense? Okay? Now, does either one of these make sense? $16.7 makes total sense because we would go over here, starting here at the origin at 0, over here 16.7 feet, and then we would go up a certain amount and over, and we'll plug it in to find out our y value as well. 16.7 makes sense. What about negative 10 point whatever? Not really, and we talked about that. Sometimes you get extraneous solutions because mathematically they make sense and mathematically they work, and there's a negative 10 over here someplace that works mathematically. But for our pool problem, for our fountain here, our beautiful, lovely, aesthetically pleasing fountain, the negative 10 is useless, and that's okay. But it's, it's really important that you all have the sense to go, now wait a minute, what are we talking about here? We're talking about a fountain. That negative 10 is not a good answer. Okay? And so you'd want to write that on your quiz. While negative 10 is mathematically correct, in the real world, it's not usable. Something like that. Okay? So we got this, and then we also need a y value. We have the x, negative 6 or positive 16.7. Then how do we find our y? How do we find our y? Renee, what are you talking about? Yeah, there we go. We can say f of 16.7 equals negative 16.7, other way around. No, wait, would that be right? No, that's right. 16.7 squared plus 20 times 16.7 minus 51. What do you get? You're on it? Okay, cool. What are we up to? Oh, 15. That's just about right. If you go over 20, they start to lose it. Seems big. Seems big. Are you? Oh, my gosh, you all. Order of operations. Are you doing this? Are you going negative 16.7? I gotta focus. Gotta focus. Now this is important. Negative 16.7 squared. That's, okay. Is this what you're doing? Yeah, you put yours in parentheses? Okay, good. Good man. Because your calculator will lie to you because it uses order of operations. Make sure you are doing the right one. Okay? Make sure you're doing the right one. So then we have 16.7 comma, oh, thank you, switch over. There we go. No, it's this one right here. What in the heck is going on? Oh, you hit power? Oh, okay. It'll come up. Come on, cycle through. No? Here we go. So then we had 16.7 comma 4.4, you said? 4.1 would be our coordinates for the two fountains intersecting. And that's some beautiful math. You know, and Abby, when you do that, Brett will go, whoa, you're my dream date. Yeah, that's it right there. Because you can do math. Okay, questions? Questions. Make sure that all of you can do this both algebraically and then check it graphically. And then how cool will you be? Because you don't have to say, is it right? You'll know that it's right. Okay? Questions. Come on, Levi, is that okay? You can do that on your own? Okay. Amy, where are you? Is that okay? All right. Okay. Well, no, I just see the top of your head, so I thought she's either buried in her work or she's crying or something. All of the above? Crying because the math makes you so happy? Tears of math joy?